this is Spencer and Jessica, and we're back for the fourth and final simulation.
Hi, so it looks like we are back where we left off. I see data in New York, Atlanta, and Des Moines. But what are these new colors inside the tables?
I'm glad you asked, Jessica. What these colors represent are partitions of the data. In this particular simulated data model, what we're partitioning by is the region that the customer data is in. So we have blue representing rows in these tables that were originated in the United States. Green represents rows that were originated in the EU. And red represents rows that were originated by customers in China.
Cool, so what exactly is a partition then?
Well, let's not get that confused with how Cockroach partitions data at the lowest level, which are these ranges. What partitions are in a relational database, and they exist and they're supported in Postgres, in SQL Server, in Oracle. Partitions are logical segments of the table, and typically, traditionally, partitions have been used in order to store some data on different kinds of media within the monolithic system, typically so that you can take, say, the most recent data, so segment by timestamp, for example, and keep that on the fastest storage, the most expensive storage, and that also allows you to have a smaller working set of data to back up quickly and restore quickly in case there's a problem.
So what's the difference then between table partitioning in CockroachDB and in one of these monoliths like Oracle?
Well, that actually plays on some of the strengths we've already covered with CockroachDB, its ability to geo-replicate data. In the same way we can geo-replicate the replicas of any particular range, we actually can control for the partitions of a table exactly where the replicas live. So that will allow us to, for example, store replicas of data for US customers' data only in the United States and replicas of Chinese customers' data only in China.
So I asked you about the colors. Let's go back to those. What do those colors actually mean?
Right, so blue again is customer data in the United States, green is the EU, China is in red here. So when we start the simulation, you'll see that there's going to be traffic just like we saw before. But what we want to do now is expand this cluster. So it goes beyond the United States and actually includes facilities, 3 new ones in the EU and 3 new ones in China for a total of 9 facilities. So let's get that started. We're going to click here and you can see we've zoomed out and there is heavy rebalancing traffic occurring. And remember, there's 15 nodes in the United States rebalancing now to 15 nodes in the EU and 15 nodes in China. So this rebalancing can happen quite quickly. You can see that we're left with the blue data in the United States, the green data is being moved to the EU, and the red data is moving to China.
That was fast.
Yeah, so again, we get to use the aggregate bandwidth of the cluster to do this rebalancing. Now, again, it's also a simulation, so things are sped up. You can imagine that, and there's much less data than you'd have in a real system, but this is, again, a simulation.
So what's actually happening in, say, China?
All right, let's zoom in. So in China, what do you see here?
I see Beijing, Shanghai, and Shenzhen. And how many nodes can you zoom in further?
Sure, so let's take a look at Shanghai. So there's 5 nodes here, and you can see that there is always the middle replica being stored in Shanghai. So just like we saw originally, we're sparsely storing the data, but as you can see, it's only the middle replica.
This looks exactly like it looked when you zoomed in on New York City. The 5 nodes, data across all of them, really sparse. This looks the same.
The big difference here, of course, is that it only contains Chinese user data. Now, and again, if you take the 5 nodes in Shanghai and you look at these grids next to them, this zoomed out view is like the onion paper layers all being composited on top of each other. So we're seeing all of the middle replicas laid out here. All of the first replicas are laid out in Beijing, all of the third replicas in Shenzhen. Now there is one additional complication here. So if we zoom out of China to the global view, you'll see that this one table, registration, actually has replicas in the United States, in the EU, and in China. That's because this table is not geo-partitioned, it is geo-replicated. So we have replicas in all three of our major replication regions. That's because even in a global service where you're partitioning data by where a customer's origin is, you still are inevitably going to need some kind of global control plane, some sort of single sign-on, for example, that allows customers to globally access the service and then be routed to the appropriate region where their data lives. Great, so that actually is the
And
let's just say we can just cut this part out. So, and as you can see here, this data continues to grow. And if you leave this simulation, these boxes will shoot off the side of the screen. But what's happening is these ranges are splitting, new ranges are being created as data is written. These are things we haven't covered in the simulation, but it's all part of the sort of magic of Cockroach. These things grow and they expand and they make sure that there's enough replicas so that you have high availability of your data. So the important thing from the perspective of geo-partitioning is it's very important in this new evolving landscape to keep customers' data next to the customer. You have a global service, you have customers in Australia, they shouldn't have to wait 500 milliseconds to get their data from the East Coast to the United States. Similarly, you need to keep the customer's data next to the customer for an evolving set of regulations that are popping up everywhere in the world now around data privacy. People don't want their data domiciled in outside of their sort of legal geopolitical jurisdictions. So that pretty much sums up what this simulation can show us about geopartitioning. I hope you enjoyed it, and I hope you have a better understanding of how Cockroach works.